Welcome to Astronomy Daily. I'm your host, Anna, bringing you the pulse of our cosmic frontier. Today, we're diving into a constellation of exciting developments that showcase humanity's relentless pursuit of the stars. The space industry never sleeps, and this week proves it with a flurry of activity that spans from Earth's atmosphere to the mysterious shores of Titan. We've got a packed episode exploring breakthroughs that could reshape our understanding of the universe and our place within it. Let's get into it then. First up today, the Federal Aviation Administration has given SpaceX the green light for its next Starship launch, providing final approval on May 22nd for what will be the 9th test flight of this massive spacecraft. This comes after a careful review of the mishaps that occurred during previous launch attempts. For those who haven't been following Starship's development journey, this approval represents a significant milestone in SpaceX's ambitious program to develop the world's largest and most powerful rocket system. The FAA's decision indicates they're satisfied with SpaceX's response to the problems encountered during Flight 8 back in March. During that previous launch, Starship's upper stage experienced what SpaceX described as an energetic event, a technical way of saying something went dramatically wrong. This event caused the loss of several Raptor engines and ultimately resulted in the vehicle losing control. The spacecraft eventually re-entered Earth's atmosphere over the Caribbean. What's particularly noteworthy is that this failure looked remarkably similar to what happened during Flight 7 in January. Despite the ongoing mishap investigation into Flight 8 not being officially closed, the FAA determined that SpaceX has satisfactorily addressed the causes of the mishap and that the vehicle can safely return to flight. This approach mirrors what the agency did for Flight 8, essentially concluding that the launch does not pose a safety risk to the public. One significant change for Flight 9 involves the expansion of aircraft hazard areas, or AHAs. These are airspace closures designed to prevent any debris from a launch failure from potentially hitting aircraft. An environmental review concluded that these safety zones needed to be considerably expanded based on data from the previous launches, which suggested a higher probability of failure than originally estimated. The numbers here are striking. The AHA for Flight 9 will extend east from SpaceX's Starbase facility in South Texas for approximately 1,600 nautical miles, that's nearly 3,000 kilometers, past the Straits of Florida, including the Bahamas and Turks and Caicos Islands. By comparison, the hazard area for Flight 8 extended for just 885 nautical miles, or about 1,640 kilometers. Another factor contributing to these expanded safety measures is SpaceX's plan to use a previously flown Super Heavy booster on the upcoming mission. This marks the first time they've attempted to reuse a Super Heavy booster, adding another layer of complexity and potential risk to the mission. While SpaceX hasn't announced an official launch date yet, temporary flight restrictions published by the FAA shortly after the approval announcement indicate they're working toward a launch as soon as May 27th. As always with experimental rockets of this scale, that date remains fluid and dependent on both technical readiness and weather conditions. The stakes remain incredibly high for Starship. As the vehicle designed to eventually carry humans to the moon as part of NASA's Artemis program and later to Mars, each test flight provides critical data that moves SpaceX closer to achieving these ambitious goals. But the path to creating a fully reusable Super Heavy lift launch system has proven challenging, with each test revealing new hurdles to overcome. And in SpaceX competitor news today, Blue Origin is making bold strides in the lunar exploration arena, with plans to attempt landing an uncrewed prototype of its human landing system on the moon's south pole before the end of this year. This ambitious timeline was revealed by John Kalouris, Blue Origin's Senior Vice President of Lunar Permanence, as the company accelerates its efforts to become a key player in NASA's Artemis program. Blue Origin's lunar lander is one of two systems being developed in partnership with NASA to support crewed landings on the moon. While SpaceX secured the first two flight service contracts for NASA's Artemis 3 and 4 missions with its Starship variant, Blue Origin's system has been selected for the Artemis 5 mission, establishing a competitive dual-provider approach to lunar transportation. The company's Mark 1 lander, which is scheduled for this year's demonstration mission, boasts impressive capabilities. It's designed to deliver nearly 3.9 tons of payload to any location on the lunar surface. This capacity significantly outperforms the small robotic landers that NASA is developing under its commercial lunar payload services contracts, which can carry up to about 1 ton. At the heart of the Mark I is the BE-7 engine, a sophisticated propulsion system that runs on liquid oxygen and liquid hydrogen. Assembly of the flight unit is nearly complete and is expected to be shipped to Johnson Space Center in Houston within 6 weeks for thermal vacuum chamber testing. After completing those tests, the engine will be transported to Cape Canaveral for integration with the lander before launching aboard Blue Origin's New Glenn rocket. Beyond testing technologies and operations for future Mark II vehicles, the Mark I mission will carry scientific payloads for both NASA and commercial customers. One key NASA experiment will measure BE-7 plume impingement on the lunar surface, providing valuable data about how rocket exhaust interacts with lunar regolith. Coluris also unveiled an updated design for the system's transporter module, which is a critical component of Blue Origin's lunar architecture. This vehicle is designed to launch separately on a New Glenn rocket and be refueled in low Earth orbit using excess propellant from the rocket's upper stage. The transporter would then travel to lunar orbit to refuel a waiting Blue Origin lander before a crew arrives via NASA's Space Launch System and Orion capsule. The transporter's capabilities extend beyond lunar missions, with the ability to transport roughly 110 tons from Earth orbit to lunar orbit, or up to 33 tons to Mars orbit. This opens up the solar system, Coluris noted, highlighting the company's vision beyond just moon landings. Blue Origin is also making significant progress in addressing one of the biggest challenges for long-duration space missions, propellant storage. A ground demonstration of zero boil-off cryogenic propellant storage is currently underway in Washington state. By June, the company expects to demonstrate consistent storage of cryogenic hydrogen and oxygen as storable propellants, a technological breakthrough that would be the first of its kind at this scale. This lunar demonstration mission represents a crucial step in Blue Origin's journey to becoming a major player in deep space exploration, creating a competitive landscape that may ultimately benefit NASA's ambitious plans to establish a sustainable human presence on the moon. Next up, let's move on out to Saturn. When it descends through the thick golden haze on Saturn's moon Titan, NASA's Dragonfly rotorcraft will find itself in a world that is simultaneously alien and strangely familiar. This car-sized flying vehicle, scheduled to launch no earlier than 2028, will explore a frigid realm where dunes wrap around the equator, clouds drift across the skies, rain drizzles down, and rivers flow, forming canyons, lakes, and seas. But the familiarity ends there. At temperatures of minus 292 degrees Fahrenheit, Titan's dune sands aren't made of silicate grains like on Earth, but of organic material. The rivers, lakes, and seas don't contain water, but liquid methane and ethane. This frigid world is laden with organic molecules, making it a unique laboratory for studying the chemical processes that may have led to life on our planet. What makes Dragonfly's mission so fascinating is that it isn't looking for life itself on Titan. It's investigating the chemistry that came before biology here on Earth. As Zibby Turtle, principal investigator for Dragonfly and a planetary scientist at Johns Hopkins Applied Physics Laboratory, explains, on Titan, scientists can explore the chemical processes that may have led to life on Earth without life itself complicating the picture. On our planet, life has reshaped nearly everything, burying its chemical forebears beneath eons of evolution. Even today's simplest microbes rely on complex chemical reactions to exist. The transition from simple to complex chemistry before jumping to biology remains one of science's greatest mysteries, with many steps still unknown. Titan offers a unique opportunity to uncover some of these missing pieces. What makes Titan so valuable is that it's an untouched chemical laboratory where all the ingredients for known life, organic molecules, liquid water, and energy sources, have interacted in the past. Before NASA's Cassini-Huygens mission, researchers didn't fully appreciate just how rich Titan is in organic molecules. Data revealed a molecular smorgasbord: ethane, propane, acetylene, acetone, vinyl cyanide, benzene, and many more compounds. These molecules fall to Titan's surface, forming thick deposits on the moon's ice bedrock. Scientists believe life-related chemistry could begin there, particularly if given some liquid water, such as from an asteroid impact. This is why Selk Crater, a 50-mile-wide impact site, is a key destination for Dragonfly. The impact that formed Selk melted the icy bedrock, potentially creating a temporary pool that could have remained liquid for hundreds to thousands of years under an insulating ice layer. If natural antifreeze like ammonia were mixed in, the pool could have stayed unfrozen even longer, blending water with organics and minerals from the impactor to form what scientists describe as a primordial soup. As Sarah Horst, an atmospheric chemist and co-investigator on Dragonfly's science team, puts it, it's essentially a long-running chemical experiment. That's why Titan is exciting. It's a natural version of our origin of life experiments, except it's been running much longer and on a planetary scale. Selk crater represents what scientists call a natural laboratory, one that may hold crucial clues to life's origins. When researchers try to understand how life began on Earth, they face a fundamental challenge: time. For decades, scientists have simulated early Earth conditions in labs, creating prebiotic soup mixtures of water and simple organic compounds, then jump-starting reactions with electrical shocks to mimic lightning. But these experiments typically last weeks, months, or at most a few years. The melt pools at Selk crater, however, potentially persisted for tens of thousands of years. While this is still shorter than the hundreds of millions of years it took for life to emerge on Earth, models suggest it could be sufficient time for critical chemical processes to unfold. As Horst explains, we don't know if Earth life took so long because conditions had to stabilize or because the chemistry itself needed time. But models show that if you toss Titan's organics into water, tens of thousands of years is plenty of time for chemistry to happen. This is why Dragonfly's exploration of Selk is so important. Landing near the crater, the rotorcraft will fly from site to site, analyzing the surface chemistry to investigate what could be the frozen remains of prebiotic chemistry in action. The impact that formed Selk created ideal conditions for this chemistry, melting water ice and potentially mixing it with organic compounds already present on Titan's surface. The Dragonfly Mass Spectrometer, or DRAMS, will be crucial to this investigation. Developed by NASA's Goddard Space Flight Center with a key subsystem from CNS, DRAMS will search for indicators of complex chemistry rather than specific molecules. We're not looking for exact molecules, but patterns that suggest complexity, explains Morgan Cable, a research scientist at NASA's Jet Propulsion Laboratory and co-investigator on Dragonfly. On Earth, for instance, amino acids, fundamental building blocks of proteins, appear in specific patterns. A world without life would mainly produce the simplest amino acids and form fewer complex ones. Titan itself isn't considered habitable in the conventional sense. It's far too cold for life's chemistry as we understand it, with no liquid water on the surface where organics and energy sources exist. But this is precisely what makes it valuable for understanding life's origins. If Dragonfly finds evidence that complex chemistry did unfold in Selk crater's temporary melt pools, it strengthens the case that life could emerge relatively easily given the right ingredients and conditions. Conversely, if complex chemistry didn't develop despite favorable conditions and ample time, it might suggest that life's emergence requires additional factors we haven't yet identified, potentially making it rarer in the universe than we thought. Meanwhile, back here on Earth, in a significant shift from traditional space business models, Dawn Aerospace has now begun taking orders for its Aurora spaceplane, a remarkable vehicle designed to carry small payloads on suborbital flights. This New Zealand-based company announced on May 22nd that the Aurora is capable of carrying 6 kilograms of payload to an altitude of 100 kilometers, with first deliveries projected for 2027. What makes Dawn's approach particularly innovative is their business model. Rather than operating the vehicles themselves and selling launch services as most space companies do, Dawn Aerospace is selling the actual spaceplanes to customers who will then operate them independently. This mirrors the commercial aviation industry, where Boeing and Airbus don't fly passengers. They sell aircraft to airlines who handle operations. As Stephen Powell, Dawn Aerospace's chief executive, explained during a recent webinar organized by the Global Spaceport Alliance, there are many out there who would love to have this capability and be willing to pay for it, but they simply can't get their hands on it. It's not for sale. He contrasted this with commercial aviation's approach, noting that the airline model presents us with a far more scalable model for transportation and one that we would really like to draw on. The Aurora itself has been in testing for several years, with its Mark II version reaching supersonic speeds for the first time last November, achieving Mach 1.12 and reaching an altitude of 25.1 kilometers. But what's particularly noteworthy about this vehicle is its fundamental design philosophy. This is an aircraft with the performance of a rocket, not a rocket with wings, Powell emphasized. That is to say, reliability, reusability, and ultimately scalability are not afterthoughts, but baked in from day one to enable this airline model. The upcoming suborbital version of Aurora will feature increased propellant capacity and engine thrust, plus reaction control system thrusters for maneuverability outside the atmosphere. Remarkably, these enhancements will be incorporated within the same external dimensions as the previous version, maintaining its sleek, aircraft-like profile. Dawn Aerospace expects the first suborbital Aurora to be ready for flight testing within 18 months, with a test program lasting approximately 6 to 9 months. These flights will begin at lower altitudes but rapidly progress to higher ones, demonstrating the vehicle's full capabilities before customer deliveries begin. Looking at Aurora's capabilities in more detail, the Spaceplane offers an impressive flight profile. On a typical suborbital mission, Aurora will take off from a conventional runway and immediately begin a steep vertical ascent. It will reach speeds of Mach 3.5, more than 3 times the speed of sound, and provide approximately 3 minutes of true microgravity at the peak of its trajectory. The entire flight, from takeoff to landing, takes just 1/2 an hour, with most of that time spent gliding back to a runway landing after re-entry. Powering this remarkable vehicle is an engine using 90% hydrogen peroxide and kerosene D60 propellants. When fully loaded, the Aurora weighs just 450 kilograms and requires only a 1,000-meter runway for takeoff, making it accessible to numerous existing airports and spaceports worldwide. One of Aurora's most compelling features is its rapid reusability. Dawn has already demonstrated the ability to prepare the vehicle for another flight within 6 hours, and Powell confidently stated that a 4-hour turnaround time should be achievable. That would make the first aircraft ever, the first vehicle of any kind, actually, to fly above the Kármán line twice in one day, he noted. On the business side, Dawn Aerospace is now taking orders for Aurora with deliveries starting in 2027. While the company hasn't publicly disclosed pricing, Powell suggested that a per-flight operational cost of around $100,000 is absolutely tenable, with prices potentially higher for more customized mission profiles. Each Aurora is designed for up to 1,000 flights over its lifetime, with potential revenue per vehicle reaching approximately $100 million. The market interest is already evident. Dawn has secured several customers for test flights of the Mark II Aurora, including 3 prestigious universities, Arizona State, Cal Poly, and Johns Hopkins, as well as Scout Space, a company developing space domain awareness services. Powell believes there's substantial demand for suborbital flight, even with Aurora's modest payload capacity, particularly in fields like microgravity life sciences research, semiconductor development, and defense payload testing. This innovative approach has been enthusiastically welcomed by the Global Spaceport Alliance, whose chairman George Nield pointed out, with a small reusable system that can operate from a standard runway, there's no reason why any spaceport with a runway couldn't provide regular access to space. For numerous underutilized spaceports worldwide, Aurora could be the catalyst that finally brings their facilities into regular operational use. Finally today, an innovation worth noting. Multi-messenger astronomy represents one of the most exciting frontiers in our understanding of the cosmos. It's the science of capturing different types of signals, both gravitational and electromagnetic, from the same cosmic event. But to fully realize this potential, we need eyes constantly watching the entire sky. This is where the high-energy, rapid, modular ensemble of Satellite's Pathfinder mission, or Hermes PF, comes into play. Successfully launched in March and currently undergoing commissioning, Hermes PF aims to solve a fundamental challenge in multi-messenger astronomy. When catastrophic cosmic events occur, like black hole mergers or neutron star collisions, gravitational wave detectors can sense these disturbances in space-time, but they struggle to pinpoint exactly where the signal originated. The Hermes PF solution is elegantly simple, yet technologically sophisticated. Deploy 6 small 3U CubeSats, that work together to monitor the entire sky for high-energy bursts. When a cosmic event releases a burst of gamma rays or other high-energy radiation, multiple satellites in the constellation detect it. By triangulating these signals with precise timing data, the system can identify the source location to within 1 degree of accuracy, a remarkable feat that dramatically narrows the search area for astronomers. Each CubeSat in the Hermes PF system carries 60 GaAs-G scintillator crystals and 12 silicon drift detectors, allowing them to capture a wide spectrum of energy signatures with exceptional temporal resolution. What's particularly clever about this approach is that the satellites primarily use commercial off-the-shelf components rather than expensive radiation-hardened parts, making the entire system more cost-effective. The technology isn't entirely untested either. A similar sensor system has been operating on another mission called Spirit since 2023, though it has faced some challenges with cooling systems and data downlink capabilities. The full 6-satellite Hermes PF constellation aims to overcome these limitations and provide truly comprehensive sky coverage. This capability will become increasingly crucial as next-generation gravitational wave detectors like the Einstein telescope come online in the coming years. These advanced detectors are expected to identify up to 100 gravitational wave events annually, 10 times more than current systems can detect. Without something like Hermes PF watching for the electromagnetic counterparts to these events, we'd be missing half the picture. Imagine trying to understand a thunderstorm by only feeling the vibrations of thunder, but never seeing the lightning. Multi-messenger astronomy allows us to both see and feel cosmic catastrophes, giving us complementary data that reveals the underlying physics in unprecedented detail. The Hermes PF mission stands to transform our understanding of these extreme events by ensuring we never miss the flash of cosmic lightning that accompanies the thunder of gravitational waves. As we've explored today, we're witnessing a remarkable convergence of space technologies that are opening new windows into our universe. From SpaceX's persistent refinement of Starship despite setbacks, to Blue Origin's bold lunar ambitions, these commercial endeavors are reshaping how we access space. Both companies are crucial partners in NASA's Artemis program, working toward returning humans to the lunar surface with capabilities far beyond what was possible during the Apollo era. Meanwhile, scientific missions like Dragonfly represent some of the most ambitious exploration we've ever attempted. By sending a rotorcraft to explore Saturn's moon Titan, we're not just visiting another world, we're potentially unlocking the chemical history that preceded life on Earth. Aerospace's Aurora spaceplane demonstrates yet another innovation in our approach to space access. By selling spacecraft rather than just launch services, they're democratizing access to suborbital space in a way that mirrors how commercial aviation revolutionized earthbound travel last century. Perhaps most exciting is how the Hermes PF mission connects to everything else we've discussed. As these CubeSats monitor the sky for high-energy events, they'll complement gravitational wave detectors, creating a more complete picture of cosmic catastrophes. Collectively, these advancements aren't just isolated technological achievements. They represent humanity extending its senses further into the cosmos. We're building tools that may answer some of our most profound questions. How did life begin? Are we alone? What fundamental forces shape our universe? Thank you for joining me on Astronomy Daily. I'll be back tomorrow for yet another episode where we'll take a look at more innovations. Until then, keep looking up. The sky is full of wonders waiting to be discovered. I'm Anna, signing off.